Okay, so we're going to be doing the mechanics side of things with mathematics now, changing the scenery a little bit. Okay, so this is going to be about a video about the key assessment 5 on mechanics. So I've done the pure section, and now we're going to be working on the mechanics section. Now the mechanics section, I know a few peers find it quite difficult, so I'm going to be breaking it down, really making it into small digestible pieces. So we're going to start off with question 1. Okay, a car travels along a straight horizontal road between two sets of traffic lights. Okay, so it's going to be going from traffic light 1 to traffic light 2, and the car will be moving from here to here. Okay, so that's the two sets of traffic lights, and this is the car, and this is how it's going to be moving. So from traffic light 1 to traffic light 2. Okay. In a model of the journey, the car leaves the first set of traffic lights accelerating. So straight away, we would know that it goes from here to here. It's accelerating. That's all we're told right now. Okay. It's accelerating uniformly from rest until it reaches a speed of v. Then immediately decelerates uniformly until it comes to rest at the second set of traffic lights. So pretty much what it's telling us is from the start, the speed, the velocity is 0, okay, and at the end it is 0. So from 0 it begins to increase, okay, reaches a certain point, and then begins to decrease. Okay. So the car completes the journey between two sets of lights in 120 seconds. So the entire journey is 120 seconds. So that's our first piece of information. Sketch on the diagram below a velocity time graph which represents the above model on the journey of the cars between the two sets of traffic lights. So it's telling us to draw a diagram. It's telling us specifically a velocity time diagram. Okay, so I'll try to find the rubber. It's right over here. Okay, I'm really trying to break it down over here, so it might look a little too easy maybe. So velocity time, it's asking for velocity first, so velocity would be the y-axis, time would be the x-axis. Okay, velocity over here and time over here. Now the entire journey we would know to be 120 seconds. I'm going to put seconds over here. Meters per second. Okay. So it started from rest. So it started from 0 and began to accelerate until a certain point. So it's starting to accelerate. Okay. This represents acceleration. Now if you have studied this, you would know that this is acceleration. This is kind of uniform. It's not really accelerating. It's just going to a constant speed. Okay. It reaches this certain point. I'm gonna call this t, or it reaches v. I think it did call it v. Okay. Yeah, v meters per second. Once it reached v meters per second, it instantly decelerated. So it didn't pause, didn't do anything, it just instantly decelerated. And it began decelerating until it reached rest over here where v is 0. Okay, so that's our model. Okay, so it's from 0 accelerating until it reaches v and begins to decelerate. And that's not the straightest line, but it's supposed to be a line until it reaches 0 again and it finishes at 120 seconds. So that's part A done. Okay, that would give you 2 marks. Using the model, find the value of v. Okay. It should have given us another piece of data, yes. So the entire journey, the 120 seconds, the entire journey is 1,500 meters. So from here to here, this entire thing is 1,500 meters. Now, you would know that the area under the graph would be the distance in this case, right? The area under this graph would be distance. So distance equals 1,500 meters, because distance is speed divided by time. Speed, distance, speed divided by time. Okay. Or also, if you kind of integrate it, you would also get distance. Okay. Because think about it like this, right? Velocity, we got meters per second minus 1. If we integrate it and add 1, this minus 1 becomes a 0, right? And anything to the power of 0 is 1, so it would become just meters. You can kind of think of it like that. That also works. But it's just a simple rule. It might come later on in this kind of example, but we're given this. Okay, so this entire thing is 1,500 meters, but this should be normal. You should already know this. Okay, the distance is 1,500 meters, and this is also a triangle. And what do we know about triangles? Base divided by height. Base times height divided by 2. Okay, gives us the area. Now we know what the area is. It's 1,500. Okay, and we know what the base is, but we don't know what the height is. The reason we don't know what the height is because this is the height. Okay, so if I just remove this temporarily. Oh, okay. This would be our height, and our height is V. Our height over here is V. Now we know our base is 120. So I'm going to apply all the things we already know. So we know our base is 120. We know our height is V. And we know that it's all divided by 2 and it's equal to 1,500. Okay? So we times, well, we make V as the subject of our formula, aka solve for V. Okay? So this would be 120. V equals 3,000, and we should get V as, I believe, 25, yes, 25. So that's our value for V. Now, we know what V is, that's 25. Okay? That's another 2 marks, you would have banked 4 marks already if you got this. Okay? Now, so it is given that the car accelerates uniformly for t seconds. Okay, so remember when I was talking about this t? Okay, the problem is we don't really know where t is because t is an unknown, right? So it could have reached 25 over here and then drop down. It could have reached 25 over here and then drop down. It could have reached 25 over here and drop down. The thing is, we don't know what t is. It hasn't given us a value. Okay? It could have been anything. I'm going to rub it all out anyways. Okay? Explain why there is a range of possible values for t which satisfies the requirement of this model. Okay? So, there's going to be a range of values for t only because the area of the triangle only depends on the base times height. Now the base we already got, the base is 120, and the height we already got is 25. And now we already got the area, so it's 1,500. So there can be a range where time would be from 0 to 120. Because we already kind of got the things we need, so there could be a kind of range between where t would be, if that makes sense. It's a little complicated to put into words, but that's pretty much it. Okay? Suggest one improvement to the model that would make this model more realistic. Okay, realistically speaking, okay, a car is at a traffic light and it suddenly goes off. Does that naturally happen? I don't think so. A car takes time. A car takes time to go from 0 to 20. It doesn't instantly go 0 to 20. It goes from 0, maybe 5, 0, 5, 10, 15, 20, or 0, 5, 10, 20, right? It accelerates slowly. So realistically, what this kind of model would realistically look like is it would look like this. Accelerating and then decelerating until it reaches 0. We would have more of these curves, right? Also, when it's decelerating, it doesn't instantly just decelerate. It takes time for it to decelerate. It takes time for it to slowly go down. It doesn't instantly just dip. Okay? So that's question 1 answered. Okay, so we're back. Now we're going to be doing question 2 on mechanics. This states that a car is moving along a straight horizontal road with a constant acceleration. There are 3 points, A, B, and C. So let's draw that out. A, B, and C. Okay. In that order, on the road, where AB is 22 meters, and BC is 104. Okay. The time it takes from A to B is 2 seconds. So we start off with t equals 0, t equals 2. And then t equals 4 because it takes 4 seconds to go from B to C. Okay? And now we are trying to find the acceleration. So we don't know what u is. Because the reason we don't know what u is and we can't assume that it's 0 is because in the question it's indicating that it's traveling from A, B, and C, but it's not traveling from rest. So we don't know if u is 0, if u is 1, if u is a trillion. It's not indicating anything like that. So we can't really give a value for for u. Okay, and we're trying to find out acceleration. Okay, so and you can also see that on the second question where after the first question, find the acceleration of the car. On the second question it says this now find the speed of the ar as it initially passed A. So we don't know what u is. That's what we know. Okay, so far what we have is enough, if you can see it already, for a Suvat equation. We got t, we got s, we're trying to find out a, and at some point we're trying to find out u. Okay, so we'll try make Suvat equations now. So from A to B, right, our Suvat equation would look like this. So we got 22, and we got 0. Actually, not 0, sorry. We got 2. Okay. However, we don't know what u is, and we don't know what a is. So I'm just going to pop that as u. I'm going to pop that as a. Okay. And the reason we're doing that is because we're trying to find out a. This isn't enough information, and we're also trying to find out u at some point. So due to lack of information, we also have 2 unknowns. We can use what we call simultaneous equations. Simultaneous equations allow us to find 2 unknowns, even if we don't know like one unknown or another unknown. As long as we have the adequate amount of information, we can find out 2 unknowns quite simply by just doing simultaneous equations, right? And now we will make a Suvat equation from A to C. Now, in the exam, I was getting through that, and then I thought, hey, let me do B to C. Big mistake, don't do that. The reason is because our u, for over here, our u, actually not our u, our v, right, the velocity when it reaches there, for A to B, would be the u for B to C. That would make it 3 unknowns. Now, we don't want 3 unknowns, we only want to know 2 unknowns, okay? Just going to turn on the slide. So we only want to know 2 unknowns. So finding it from B to C, we would not only not know what u is, a is, or v. So we would have 3 unknowns. It's going to be really difficult to find out each one of them due to the lack of information. So that's why we're finding out from A to C because we will still have two unknowns to work out. SUVAT. Super. Okay, so far we know that the total from A to C is 126. U is U, A is A, and T would equal to 6, not 4. Reason 6 being is because it takes 4 seconds from here to here. 2 plus 4 is 6, so there we go. Now we organize it using Suvat equations. Now we organize it in the way we try to find acceleration. Not acceleration, any Suvat equation which contains speed, time, acceleration, or u, we can use that. Right? Now, in this case, we want to use anything with acceleration, time, and u, and a, or something like that. Okay, so we would get, for this one, 22 equals 2u plus half times a times a times 2 squared. For this one, we would get 126 equals 6u plus 18a. Okay? So this is what we got so far, right? Where we have time, speed, acceleration, and the initial velocity. Okay, so now we simplify it. If we simplify this really quickly, we get 11 equals u plus a, I believe. Yes, and then for A to C, we get 21 equals u plus 3a. Okay, that's what we got. The reason this would work as a simultaneous equation is because we got u and a over here. So I'm going to rub all of this out, really tidy it up. So 11 equals u plus a, 21 equals u plus 3a. Our u's are the same, they're all in line. You can do different types of simultaneous equations. You can do y equals y, substitution, anything like that. Me personally, my favorite is y equals y. It's going to take a bit longer because, you know, you could just look at that and work out the solution. But I'm going to do y equals y. It's just my favorite. So if I just make u the subject of the formula here, we would get 11 minus a equals u, and 21 minus 3a equals u. So we get 11 minus a equals 21 minus 3a. We get a is equal to 5. Boom. Yeah, because it turned into 2a, and then we just divided it by 2, then it didn't really need that much to do. Okay, now we're going to find the initial speed when it first passed. Okay? So the initial speed. Now the initial speed is quite easy to calculate. Okay? We just substitute 5. Okay? We got that. Or we could use that. Right? It doesn't matter. I'm going to pick the easy option. I'm going to pick that one. Right? 11 minus 6. 11 minus 5. That equals 6. Boom. We got u. Right? We got u equals 6 and a equals 5. And make sure not to forget the units. Meters per second squared. Meters per second. Okay? And there we go. 7 marks. All the way. Easy. Okay, I do have to admit. Question 2, a little bit of a mess, okay? You know, at first you had to really break it down into little digestible pieces, and then all of a sudden you had to do simultaneous equations. And let me be honest, nobody, nobody. I mean, everybody can do simultaneous equations. Even my neighbor's dog can do simultaneous equations. I know I'm stuttering a lot. I'm slightly out of breath. Okay, but that's okay. All right, because we got question 3 now. All right, question 3 states particle P moves along a straight line at time t seconds. T is greater than or equal to 0. All right. Its velocity v meters per second is given by v equals 16 minus 3t squared. Okay, v equals 16 minus 3t squared. Can you see that? I can see that. Can you? Yeah. Okay, cool. All right, integrate that bad boy. So use that little integration worm thingy. Squared dot dx. What do we do? Integrate that 16. Give that bad boy a t. All right. We do minus 3t at the power divided by the new power. Okay. Now this is a special kind of integration where we're trying to find out what happens at t equals 1. All right. And we know that t equals 0. We're given through that statement, right? Find the distance traveled by p in the first second. The first second. So 0 to 1. Okay. So this special one, it doesn't have a c. So I don't get that confused, because I got that confused. That's why I'm recording this again. I'm joking. Okay, but I did record this again. But okay, let me just not get too crazy. Alright, so we're getting 16 t minus t cubed. Alright, put that little box around it, 1, 0. The highest value, of course, goes on top and the lowest goes on the bottom. Right? Plug in the values. 16, 1 minus 1 cubed. Okay? Minus 0. That gives us 16 minus 1 gives us 15. Okay? That's it. 15 meters per second. 15 meters, sorry, because that's the distance. Right? And if you have listened to question 1, you would know that if you integrate the velocity, you would get the distance. Okay? Bizarre, right? Anywho, that's question 1 answered. Boom, 3 marks. Man, if you're getting all these right, you're on a buzzer. Okay? Anywho. Alright. So, question A, distance is 15 meters. Question B, find the value of t at the instant when p changes its direction of motion. Right? What does that mean? Okay, something changes. All of a sudden, changes. Right? V equals 0. Okay, velocity is equal to 0. Find the value of t when v is equal to 0. Okay, changes motion. Every time it says that, changes motion. Just know that v equals 0. Don't even think about it. Just know. Changes motion. V equals 0. Changes motion. V equals 0. Okay? Alright. V. I'm going to write it again. V equals 16 minus 3t squared. Okay? So, find t when v equals 0. Simple. Equals 13 minus 3t squared. Move this 16 to the other side. Minus 16 equals minus 13 t squared. Okay? Now we divide it by 3. Okay? Divided by 3, you get 16 over 3, because minus divided by minus gives a positive. Alright? Equals t squared. Divide that. Square root it. And whatever the positive square root, remember the positive square root is the answer. You're going to get 2 answers because you square root it. Okay? Whatever the positive square root is, that's the answer. The negative would be wrong, because how would you have negative time? You go back in time? Come on, man, don't be silly. Okay? So this is it. So that's B. Alright? The value of t at the instant when p returns to its starting point. So that's basically when p returns to its starting point. That means s is 0. So back at its starting point, that means distance is 0. So again, we have to use our integrated value, which I wrote down. no big deal. Alright, so we got the answer for B and we got the answer for A, and we got the integrated value, 16t minus 13t cubed equals 0, right? Now we find that out, take out a t, 16 minus 3t squared, okay? Easy, alright? Really easy. Okay, you can pop this bad boy in a calculator if you want. You can get the answer. You got t minus 4, t plus 4 equals 0. Now, easy, this t has nothing. It could be t plus or minus 0, so t equals 0. T equals 4, t equals minus 4. Now, since it's told us that t is greater than or equal to 0, we can't assume, well, sure, I mean, we can assume that t is 0, but that wouldn't be the right answer, would it? Which clearly wouldn't be the negative answer. So with that out, t can't be 0 once at the origin. I think that's the answer. Yes, sir, that's the answer. 4 seconds. And you know what? You just landed. You landed. Bravo if you did. 8 marks. I'm proud of you. I really am. I don't have any words to really shed anymore. Just well done, man. Really. Bravo, man. That's 8 marks. So far, if you would have gotten all these questions, that's 8 plus 7, 15 plus 7, 21. No, 22. 22 marks. Do you understand the gravitas of this situation? Alright, I'm going to do the next question. Okay, so it seems like I was hoping to do this video before nighttime, but it seems like it's nighttime already. Couldn't find this in the computer, so I took my own test. Okay, we get started. It's car, trolley, trailer thing. It's a pulley kind of system. Okay, we got a car and a trailer. Okay, the mass of the car is 800. So this is 800 kilograms. Okay. Or we can put 800g. I'm not going to really put it there. The reason we put 800g is because g is for gravity. Alright, hopefully that's very clear. Yeah, that's clear. Okay, and then we got the trailer, 600g. Of course, can't forget the tension in the middle. We got 2 tensions. And it splits in the middle. We got R, which is what we're trying to find out. We got the resistive force, which is 400. Okay, we got the acceleration, 0.6 meters per second squared. Okay, we are trying to find out. It says show that R is 500. This is 3 marks. Okay, so we find out the force on each object. So we find out the force on car. I'm gonna call this car. I'm gonna call this C, and I'm gonna call this T, just to make things a little easier. Now I'm gonna put TR and CA because don't want to confuse tension and everything. We're running out of battery here. Okay, so this is gonna take quite a bit of space, but what we're gonna do is there's 2 ways of doing it. Now I did the 2 ways, which kind of brought me to the next question really easily. Okay, now there's 2 ways of doing it. Okay, so first of all, we have to find out the resultant force on the car by using force equals mass times acceleration. Okay, that's Newton's law. Okay, this is on CA, the car, and this will be on TR, the trailer. Okay, and we're going to do the resultant force, which is on the trailer. Okay, And now we just put in the data. Okay, so we're gonna put the resultant force that we got for the car and the resultant force for the trailer. So the resultant force, by the way, I did forget one thing. The driving force for the car is 1,740. Can't forget that, of course. So to find out the resultant force, we have to take in all these forces away from each other. So we got from the car, we got the tension, we got 400, we got 1,700. Each go separately. So whatever is the driving force, whatever force is kind of driving, how I look at it, right, is if I see the acceleration going forward, whatever is forward is positive. So in this case, the acceleration is going that way, so the driving force is positive, and whatever's opposite the acceleration is negative. Okay, so 1,740. And if you still don't understand that, basically, you see how this arrow is going that way, that driving force is that way, so this is positive. If that was that way, then, and that was still that way, that would be negative. Hopefully that makes sense. Okay, 1,700 minus 400 and minus t is equal to mass times acceleration, so 800 times 0.6. Tidy things up a little bit, so we got 1,340 minus t is equal to 480. Okay. If we move t, try and make t the subject of a formula. Now, I kind of did it in a way, but if you do it quickly, you should get t is equal to 860. Now, I know we're trying to find out what r is here, but it's quite simple. We can use t to find r, because this is quite easy. You find 1, you could use t to find the rest, innit? So for this one, right, you got t as the driving force, so t is the positive. T minus r. T is opposite the acceleration, so it's the negative, right? I'm doing a lot of weird gestures. Okay, and that is equal to 600 times acceleration, which is 0.6. Okay, so that would be equal to, if we apply the tension, because the tension is the same, t is t, it doesn't matter what kind of scenario you put it in. Okay, so that would be 860 minus r is equal to 360, and r would be, ta-da, 500. Okay, now the next question says find the value of t. Find the value of t. Hello, found it. Okay, we found this, all of this, it took what, couple minutes, boom, 6 marks. Okay, the next question. I'm gonna look at the next question. It says, show that after the tow bar brakes, the deceleration of the trailer is 5/6 meters per second. Okay, so after the tow bar brakes, let's draw it out, okay? After it brakes up, begins to decelerate. And this is not the most profound car, I'll admit. Okay, we'll still apply the units. Okay, it's going downwards. This one is 500. And this one is decelerating. So 5/6. Okay, show that after it brakes. So we're given new information. At the instant when the speed of the car and the trailer is 12.5, the tow bar brakes. So the acceleration is 12.5. The trailer moves further distance, the meters, before it comes to a rest. The resistance to the motion of the trailer is modeled by a constant force of magnitude 500, and tells us show that is 5/6. So So the deceleration, this is x, or kind of like that, or maybe it's the opposite. I don't know. It's not really going the opposite. 1 second. Okay, I'm back. Okay, so after thorough analysis, it's going to be accelerating like this. Okay, just because it's decelerating doesn't mean it's still not accelerating. It's just going accelerating, but it's now less. So it was, imagine if it was 5, it would go to 2. It's still accelerating at 2. I mean, it's not like it's gonna. But at some point it does reach rest, so it does stop. Okay, but it's not going backwards. So it shouldn't. The arrow shouldn't go that way. Anywho, all right. So, at first, initially, when I looked at this, I thought, you know what? That looks like a very clean Suvat equation. Perhaps not. No Suvat. Okay. We can find this out quite easily, and we can do this by doing the resultant force. F equals ma. Okay. Now it's going this way, and the acceleration is that way. So this one will be negative, right? I said this before. It will be negative 500. Okay. And the mass 600. And gravity, we don't know gravity. Gravity, it's not about the gravity, sorry, I am mistaken. It's acceleration. Acceleration we don't know. Okay. Find out acceleration minus 500 divided by 600. And in other words, that's 1 minus 5 over 6. Boom. Easy peasy. Okay. Now, it's telling us find the value of d. Now d, as I previously mentioned, d is the distance. Okay, find the value of the distance that is moved. Okay. Now we have the solution on the other side. And now we start applying super. Okay. So we know the acceleration, the deceleration. Okay. We know the speed. Okay. So let's just apply it then. Alright. Suvat. Simple. Suvat. Suvat. Now the t we have has not been mentioned, but we know the acceleration will be minus 5 over 6. We know v, because it comes to rest, it will be 0. We know u is 12.5. That's how when it broke, right? That's when it reached 12.5. That's when it broke. So initially it was 12.5. Okay, and s is d. So we don't really know what that is. Now there's a formula. There's an equation for this. If you look at the formula book, you would get v squared equals u squared plus 2as. Okay, now you apply everything. V being 0 is 12.5 squared plus 2 minus 5 over 6. Sorry, there's barely any space. S. Okay, 0 equals 156.25 what is it? Minus 5 over 3s. Okay? Pop that bad boy on the other side. We got minus 156.25. And you also divide that over here. We got minus 5 over 6, not 3. Oh, it is 3, yeah. Because you times that by 2 and everything. So that is 3. And you get S. And S is 93.75. That's your solution, guys. And that is, well, not really S, actually. We were trying to find D. So D is actually that. Meters. Okay? So, now for the last question. Now to really get your bang for your buck, or whatever it's called. That last question. 2 marks. By the way, I'll tell you the total amount of marks for this one. Don't jump. See, it's a lot of marks. Okay, so 2 marks. The road is not light. Okay. Sorry, the rod, the rope. When we are holding 2 things together, right? Say this pen. Oh no, that's a bad example. Right. When I'm holding I'm the car. This hand is the car. This hand is the trailer, and I'm pushing. Yeah. We can't assume that my 2 fingers are light. In this kind of example, we're assuming that it's light, but in this kind of scenario, it's not light. So we say that the rope realistically is not light. 1.1, there we go, 1 mark. And second point, roads are usually bumpy. Roads are roads, man. They're gonna be bumpy. There's gonna be problems along the way. Roads are gonna be bumpy. They're not gonna be smooth. You're not gonna be accelerating properly. It's not frictionless. There's gonna be things that are gonna be slowing you down. The acceleration is not gonna be proper. So roads are bumpy. Okay, roads are bumpy. That's it. You know what? If you got this question, and I must say bravo if you did, because I didn't at that time. You would have gotten 6, 10, 12 marks. Alright, combined with the entire mechanics side, you would have gotten 33. 33 marks. That easy. Give me my money, bro. Alright, good luck, guys. I'm going to be making more videos soon, hopefully. If you do enjoy the content, please subscribe, hit that like button. If you don't, it's fine, I'll still be uploading. See ya.